Welcome to my YouTube channel. Today I am going to deliver a lecture 2 upon the complex function harmonic function. So what is harmonic function? It's a definition. A function, a real function phi of x and y are said to be harmonic function on a region R if it has continuous second order partial derivatives and satisfies the Laplace equation. That is del 2 phi del x2 plus del 2 phi del y2 is equals to 0. So this is if the function phi of x and y satisfies these equations, del 2 phi del x2 plus del 2 phi del y2 is equals to 0 in a region R, then phi is said to be harmonic function. So let us check phi x comma y is equals to x square minus y square. We want to show that this phi is a harmonic function. So let's check. So del phi del x is equals to 2x. So del 2 phi del x2, so like this. So del 2 phi del x2 is equals to 2. Del phi del y is equals to minus 2y. Differentiate this partially with respect to y, we get minus 2y, and del 2 phi del y2 is equals to minus 2. So adding we get del 2 phi del x2 plus del 2 phi del y2 is equals to 0. So phi is harmonic. So this function is the harmonic function. So phi is harmonic. Function. If z is equals to u xy plus iv xy is analytic in R, in some region R, then u and v are harmonic function. So we want to, this is my claim. So this is my claim. let fz is equals to u plus iv is analytic, then then fz satisfies, then u comma v satisfies CR equation. So you have explained this in my previous lecture that fz, u and v will satisfy the CR equation. So what is CR equation? CR equation, del u del x is equals to del v del y, and del u del y is equals to minus del v del x. So these two relations are called CR equation. Okay, so since fz is analytic, so u and v will satisfy the CR equation. Okay, now this is called as 1, this is 2. So differentiate u, differentiate 1 partially with respect to x, we get, so del 2u del x2 is equals to del 2v del x del y, del x or del v del x, so this is del x del y. Differentiate 2 partially with respect to y, we get, so del 2u del y2 is equals to minus del 2v del y del x. So since v has the continuous second order partial derivative, v possesses second order partial derivative, so these two are same. So adding, so call this 3, this is 4. So adding del 2u Cauchy-Schwarz equation, by the help of Cauchy-Schwarz we call this as equal, plus del 2u del y2 is equals to 0. So u satisfies harmonic equation. So u is harmonic equation. U is harmonic. Similarly, we can show that V is harmonic by same process. So we are able to find the relation del 2v del x2 plus del 2v del y2 is equals to 0. So V is harmonic. So my claim is, if FZ is analytic in that region, so in that region U and V are harmonic function. Now these U and V are called as harmonic conjugate. In these U xy and V xy are called harmonic conjugate. So what is harmonic conjugate? So this is important, harmonic conjugate. So now it's a problem. Upon harmonic conjugate. If U is equals to x square minus y square, we already said that U satisfies the harmonic. U is a harmonic function. So find the harmonic conjugate. Harmonic conjugate V. So del u del x is equals to 2x, del u del y is equals to minus 2y, del 2u del x2 is equals to 2, del y. Now del v del x, since v is harmonic conjugate, so del v del x is equals to minus del u del y, and del v del y is equals to del u del x is equals to del v del y, del v del, so del u del x. Del u del x is equals to del v del y, and del u del y is equals to minus del v del x. So these are true. Okay. Now, so since v is harmonic conjugate, so v will satisfy this relation, CR equation. U comma v satisfies the CR equation. So now find v. So find v. So dv is equals to del v del x dx plus del v del y dy. So now del v del x is equals to minus del u del y into dx plus del v del y is equals to del u del x. So del u del x into dy. So minus, so del u del y is equals to minus 2y. So this is minus 2y dx. So del u del x is equals to 2x dy. So this is minus 1 minus 2. So 2y dx plus 2x dy. So we find dv here. So this is equals to, so dv. So dv is equals to 2 common. So y dx plus x dy implies dv is equals to 2 into d of x. Sorry, d of x y. So integrating we get v is equals to 2xy plus c, which is the conjugate, harmonic conjugate. So we have been able to find the conjugate, harmonic conjugate phi v is equals to 2x plus c. So that's